we go. I want to give acknowledgement to Doug Bear, who was a graduate student on this project and has done quite a bit of the work that I've been involved with looking at waterborne pathogens. One of the things that we wanted to look at with this riparian project was any effect of cattle and the relationship to waterborne pathogens. I wanted to present the slide again that talked about in Iowa the number of stream or rivers that were impaired, and the number one reason why was bacterial load. And the way we look at bacterial load in surface water is trying to look at coliforms in the water. So that was one of the strategies that we used in this study, is to try to look at coliform numbers in the surface water in the pastures. The ones that we were interested in were coliforms, because that's the method EPA recommends to try to look at bacterial contamination in water. And then as part of that study, we also tried to look for the E. coli 0157H7 to see if we could, the presence of that particular bacteria in the coliform population. We also looked at some bovine viruses, enterovirus, coronavirus, and rotavirus in the water as well, to see their presence. The pathogens can exist anywhere where production animals are located. Some pathogens can only affect other animals. Some are what we call zoonotic, meaning that they can be transmitted from animals to humans or humans to animals. And then the pathogens that we are concerned about can be released into the environment in the air, soil, and water. We were interested in the water. And again, I want to talk about what we found when we looked for coliforms and E. coli 0157H7 in particular, how they got in the environment, why they are of a concern, and when and why they occur in the water. The pathogenic bacteria and viruses that we were concerned about in this study have been shown to be from several animal species or several different sources. And as this slide shows, wildlife, pets, companion animals, agricultural animals, and humans are all potential sources. And in particular, human contamination of water has been shown from defective treatment plants. And most of the waterborne disease outbreaks that we hear about or reported are usually with human health issues, not particularly animal health issues. And I put a couple of cases in this presentation just to show in general that waterborne diseases do occur, mostly associated with humans. And in 2001, 2002, there were 31 different waterborne disease outbreaks in 19 different states. 2005 to 2006, there were 20 outbreaks, and some of these, besides just being enteric disease associated, also could be associated with respiratory illness and hepatitis A, a viral infection of the liver. In order to look for bacteria in the water, it's not practical to just grossly or microscopically examine the water and be able to determine what's there. So what we do is we look at coliforms in the water. There's a standard method. EPA has several standard methods to look at coliforms. We used a standard method that involved filtration, and we looked at number of coliforms per 100 mils. And these coliform are the indicator bacteria that are supposed to help us evaluate water for contamination. And one thing I'd like to make fairly clear is that the indicator bacteria, the coliforms that we look at, are not particularly pathogenic in and of themselves, but they just indicate fecal contamination from from animals or wildlife or people. And this is a little bit of a breakdown into the how we looked at what was in the coliform population, and that the E. coli 0157 is a subpopulation of bacteria that's in the total coliform that we looked at. This is just a microscopic view of the E. coli, the subpopulation in the coliform bacteria. And again, the total coliform is what we look at, is what we measure. Total coliform per 100 mil is how we measure that. Fecal coliform is a subgroup, and E. coli 0157 was a subgroup of the fecal coliforms. Some things about the E. coli 0157 is that it does not cause illness in animals that harbor the disease, but only in humans when they ingest it. And there's been great concern about the spread of 0157 and the potential for it to cause illness in humans. In humans, it's a potential deadly bacteria pathogen that can cause death or severe illness, and it does not usually take very many organisms in order to cause death in humans. And we were interested to see if we could find E. coli in the environment where we saw coliforms in association with grazing animals, because the E. coli has been shown to persist in a water environment, been shown to be present in cattle, and probably more commonly in feedlot cattle, but has also been shown to exist in grazing cattle. These are a study where they looked at beef and dairy operations to show the distribution of E. coli 0157, and in certain management situations, it'll have a high prevalence in the herd, and also that even though within the herd it can be a high prevalence, it may only be a small percentage of the animals in the herd that actually carry and spread the E. coli. So from previous studies, it looks like the E. coli that one of the organisms we were interested in is a transient member in the cow. It shows that dietary stress can increase the shedding of 0157, and there are other influences besides diet too that can increase the shedding of the 0157. Again, this was a slide Dr. Russell mentioned. This is our plots of the coliform concentrations upstream and downstream over the months that we surveyed. This is for year 2007, 2008. We don't have 2009 data in here yet, but it looks fairly similar to this. And as Dr. Russell said, in the coliform counts that we did, the coliform counts would vary widely in the pasture. We did find that there was some correlation with high rainfall events and coliform concentration in the water. And in particular, we did find in some of the pastures that we had, the downstream water from even CRP ground that we anticipated would have maybe lower coliform counts was actually higher in some instances in the incoming water than in the water leaving the pasture than the downstream water. So we were surprised to find that some of the upstream water coming into the pastures was actually higher in coliform than what was leaving in the downstream. And in 2 years of sampling, or actually 3 years, this will be the third year, the E. coli 015787 was not found in any of the surface water. So in our study anyhow, it looks like the presence of coliforms don't do not indicate that the E. coli 015787 is going to be present in that type of management situation in those type of samples. We also were interested in viral transmission or viral presence in water. It has been shown that there are pathogenic viruses, human pathogens that can be present in water and be spread as a waterborne disease. Hepatitis A and Norwalk virus are two examples. And some of these have been shown to be spread from municipal sludge or manure or human waste or tank effluent. Can contribute to human viral pathogens being present in surface water. And in the study that Dr. Russell's working on now, we looked for 3 bovine viruses, bovine enterovirus, bovine coronavirus, and bovine rotavirus. We did find these viruses present in the surface water. This chart shows that the incidence, even though we did find bovine viruses in the water, all 3 of the viruses that we looked at we were able to recover, but they were fairly low incidence. Anywhere from less than 1% to maybe 7% of the time. The other thing that was significant was when we did find those, when we had cattle within the sampling area within 3 days of when we collected samples, there was an increased chance that you would find a bovine virus in the surface water. And this chart tries to demonstrate that as well. So viral pathogens, there's little evidence to show that they're shed from cattle or that they get into the water. Bovine rotavirus in particular, there has not been much evidence to show that it's a potential human pathogen. If it's a pathogen at all, it may be just an animal-to-animal pathogen, but it's in our study was not present in the water in a very high percent of the time. And viruses from animals may be able to be transmitted from animal to animal, but there's little evidence to indicate that any of these viruses may be significantly transmitted from animals to the environment or animals to animals. And that the use of bacterial indicators like coliforms aren't a useful predictor of viral pathogens. And in fact, there's a lack of association between the coliforms and the viruses that we found in our study. So that the bacterial indicators, the coliforms that we looked at, had low predictive ability for any enteric virus and little correlation to any virus in the environment. So we can say that the fate of the coliforms or bovine viruses that we looked at in the environment are separate, need to be thought at as separate pathogens, because the coliforms themselves are more susceptible than the enteric viruses we looked at to extremes in pH or salinity or temperature. Bacteria are more easily removed by filtration than viruses, and even though viruses may be able to persist and move generally in the environment compared to bacteria, that we don't see much evidence of cattle on pasture being able to shed virus into the environment. So the main measure of pathogenic potential of water, of most surface water, is to measure coliforms. The coliforms may or may not actually indicate any pathogenicity. So when we talk about pathogens in water, measuring coliforms may not be an appropriate way to try to look for potential pathogens. And the coliforms in our study did not have any correlation whether viruses would be present in water or not. Any questions?
Okay, thanks.